Hello students, my name is Alok Semwal and today's topic of discussion is affinity chromatography. In this I will discuss introduction, theory, instrumentation and procedure of affinity chromatography. So affinity chromatography was discovered by Pedro Quattrocascos and Meyer Welchek. It is a type of liquid chromatography particularly used for the separation, purification, identification and specific analysis of sample components. Next is theory or principle of affinity chromatography. Affinity chromatography utilizes the advantage of a specific binding interaction between the analyte of interest and a binding ligand. Analyte is usually dissolved in the mobile phase and ligand is immobilized on the stationary phase. This chromatography technique is based on the highly specific reversible biological interaction or molecular recognition called affinity. Affinity refers to the attaching force exerted in different degrees between atoms which force them to remain in combination. For example, affinity of antigen with an antibody and affinity of enzyme with an inhibitor. In affinity chromatography, the stationary phase consists of a support medium on which the substrate is bound covalently. Substrate is ligand. They usually bond in such a way that the reactive groups responsible for binding of the target molecule remains exposed. In the chromatography procedure, when the analyte, which is crude mixture of substances, is passed through the chromatography column, substances with binding site for the immobilized substrate bind to the stationary phase, while all other substances are eluted in the void volume of the column. Once the other substances are eluted, the bound target molecule can eluted by the use of competing ligand in the mobile phase or by change of pH, ionic strength or polarity conditions of the solvent used. Following picture is showing the complete procedure of affinity chromatography. This is the column used in affinity chromatography. Here these yellow balls are of affinity resin. Blue ones are target proteins. Green, sky blue and purple ones are other components of complex protein mixture. First step is binding, in which ligand bind to the matrix, which is affinity resin. Second step is washing. In this step, washing is done by the mobile phase. And in the last step, target material is recovered by various techniques. Components of affinity chromatography. First component of affinity chromatography is matrix. The matrix is an inert support to which a ligand can be directly or indirectly coupled. Matrix materials should have following characters. It should be chemically and physically inert. It must be insoluble in solvents and buffers employed in the process. It must be easily coupled to a ligand or a spacer arm onto which the ligand can be attached. And last, it must exhibit good flow properties and have a relatively large surface area for attachment. Examples of matrix material include agarose and polyacrylamide. Second component of affinity chromatography is spatial arm. It is usually a chain of carbon and or other atoms that keeps functional groups away from the solid matrix to which it is covalently bound. It is used to improve binding between ligand and target molecule by overcoming any effects of steric hindrance. Third component of affinity chromatography is ligand. Ligand is a molecule that binds reversibly to a specific target molecule. Criteria for the selection of the ligand is the nature of the macromolecule to be isolated. For example, when a hormone receptor protein is to be purified by affinity chromatography, the hormone itself is an ideal candidate for the ligand. For antibody isolation, an antigen or heptane may be used as ligand. Next are steps in affinity chromatography. First is preparation of column. The column is loaded with solid supports such as saffrose, agarose, cellulose, etc. After this affinity medium is equilibrated by using binding buffer, the ligand is selected according to the desired isolate and spacer arm is attached between the ligand and solid support. As I discussed earlier in the last slide, spacer arm is usually a chain of carbon and or other atoms that keeps functional groups away from the solid matrix. Second step is loading of sample. In this, solution containing a mixture of substances is poured into the elution column and allowed to run at a controlled rate. Target substances bind specifically but reversibly to the ligand and unbound material washes through the column. In the last step, target substance is recovered by changing conditions to favor elution of the bond molecules. This is usually done by using a competitive ligand or non-specifically by changing the pH, ionic strength or polarity. Target protein is collected in a purified, concentrated form. Following are the applications of affinity chromatography. Thank you.